All right, so I'm going to recap this first problem right here real quick. We want to solve using substitution. So in a problem like this where the equations are both kind of like in standard form, we want to find an equation with a variable that has just the variable, no numbers attached to it, if that's possible. So like on this first problem, the second equation has this y right here that is just y. This is going to be the one that we want to solve for. So I'm going to use the second equation and I'm going to solve for that y right there, okay? So that means I'm going to add 2x to both sides. This is going to get me this y by itself. So they give me y equals 2x minus 3, okay? Now that's important because I didn't have to divide by anything here. I just have y equals automatically. If I have to divide by something, I might be creating fractions, and I don't want to do that, all right? I just want nice numbers, okay? If I can avoid fractions, I avoid fractions. Even me, I try to avoid fractions. Now, this gives me a y that I can plug into the other equation for y right there, okay? This y and this y are the exact same thing. So that means 2x minus 3 that I just found for my y here in pink is the same as that y up on the first equation. So I can go ahead and substitute that right now. So I'm going to rewrite this top equation, 3y plus 4x equals 14. Notice I didn't write y because I'm going to substitute the 2x minus 3 in for y. The variable is no longer y, it's 2x minus 3. I made a substitution, okay? I plugged it in. Now this equation that I have sitting here is just a single variable equation. I can solve for that variable now. I can solve for x. So I'm going to distribute. So I have 6x minus 9 plus 4x equals 14. So now we're right back in chapter 2. It's like September all over again. Combine like terms. 6x and 4x is 10x minus 9 equals 14. Solve for x still, get the x term by itself. We're going to add 9 to both sides. 10x equals 14 plus 9 is 23. Divide both sides by 10. So I have x equals 23 over 10. That doesn't reduce. Okay, so now we know what x is. We got to know what y is. We need the ordered pair. So we're going to go up to this y equals 2x minus 3 equation that we have, and we're going to plug that 23/10ths in for x. So we have y equals 2 times x, which is 23 over 10 minus 3. Okay, so 23 over 10 right here. Now we just got to figure out what y is. So 2 times 23 over 10 is 46 over 10, and that's going to reduce. So we have y equals 46 over 10. That reduces to 23 over 5 minus 3. And then we just need to figure out what that's going to be. So 3 has to have a common denominator. The common denominator is going to be 5. So we have minus 15 over 5. So 23 fifths minus 15 fifths is going to give us 8 fifths. So we have y equals 8 fifths. So now we write our answer as an ordered pair, 23/10ths, comma, 8 fifths. That's it, okay? All of our answers have to have ordered pairs to them. So that's how you do it, okay? Now the main idea is up here in green. What y is in one is going to be the same as what y is in the other. What x is in one is going to be the same as what x is in the other. We make a substitution, swap one for the other. So let's do the other equation now. The key is we have to find a variable that works for both, okay? Or sorry, that works for not having to divide by anything. So I'm looking in the bottom equation here, and I see this x sitting here. It's just x. I don't have to divide, so I'm going to solve for that x, okay? You don't have to always solve for y. You can solve for the x also. So I'm going to solve for this x by subtracting 3y. So that gives me x here equals negative 3y minus 7. Okay? Now, that's important because I didn't have to divide, I didn't have to make fractions. This is great. So now I can take this x and I can substitute it into the other equation for this x. Okay? What x is in one is the same as the x in the other, so I can substitute it. So now I'm going to write the other equation down. 6y plus 5x equals 8. Okay? In that group of parentheses right there is what x is, and that x is negative 3y minus 7. I'm just plugging that in for x. Okay? So that substitution has happened now, and now I can solve. Notice that this equation just has y in it. So now I can solve for y. I have 6y, distribute, minus 15y, minus 35 equals 8. Now combine like terms. So this is going to be negative 9y minus 35 equals 8. Okay, now get y by itself, so we're going to have to add 35. All right, now we got negative 9y equals, what is that, 43, and then divide by negative 9. So y is negative 43 ninths. That doesn't reduce. Okay, so we have y. We need to find out what x is. So once again, we can go up here into that equation that is solved for x and plug in what we found for y. Now, most of the time in Algebra 1, we're not going to get these crazy fractions. Most of the time, you're going to get really nice numbers, just integers and whole numbers and stuff like that. These are crazy fractions. I wish that I had better examples up here where we'd get nice numbers, and it seems like it's way easier to work with. So sorry about these examples. They're better on the homework, trust me. Okay, so we plug in this negative 43 ninths into this equation. So we have x equals negative 3. We found out y is negative 43 ninths. And then minus 7 to finish that off. Okay, now we just got to figure it out. So we have x equals, now a negative times a negative is a positive. So then we have to go 3 times 43 divided by 9. Or we could go 3 divided by 9, which is 1/3, times 43 gives us 43 over 3. We can do that. And then minus 7. Then we need to find a common denominator, which is going to be 3. So 7 turns into how many thirds? That's going to be 21 thirds. So 43 thirds minus 21 thirds. This is going to give us x equals 43 minus 21 is 22 thirds. So now we have a ordered pair. 22 thirds negative 43 ninths. Remember, it goes x, comma, y. The x coordinate was 22 thirds, so we wrote that first. That's our ordered pair. That's how you do substitution, okay? Doesn't matter what the numbers are that you wind up coming up with. If they're fractions, fine. If they're not fractions, awesome. It's easier, okay? Now, there's one more thing that I want to do here. We somehow in the video skipped the very first problem in the section. So we're going to go back to that real quick. So in the notes, go back to the first problem in the section here. Okay, here we are. And this problem says a board game allows players to trade game pieces for equal value. The diagram shows 2 fair trades. The hotel is worth $2,400. So this thing right here, I guess, is the hotel. How much is a car worth? All right. So let's see. We have, in this first fair trade on top, we have 3 cars, and then this gold thing right here is supposed to be $100, equals 1 house. And then we have 2 houses, a car, and then another $100 equals a hotel. So on a problem like this, you can actually really just use logic. But what this is trying to get you to do is understand substitution, okay? Like before the section starts, we're trying to understand substitution. So if I have 3 cars and $100, I can get a house. But down here, we have 2 houses, a car and $100. And that's going to give me a hotel. But they told us that a hotel is worth $2,400. So really, this hotel right here is actually just $2,400, okay? So what we can do is we can say, all right, if I have 1 house, that gives me 3 cars and $100. If I say that each car is like C and 100, I get a house. I have a house right here and a house right here and a car and 100. I get 2,400. I can turn this into an algebra problem pretty quick. So this first problem up here, this first fair trade, tells me I have 3C plus 100 equals a house. And then the second fair trade tells me I have two houses plus a car plus 100 equals 2,400. Well, that's great, but if I take one of these houses and I turn them into these houses down here, then each house is giving me 3 cars and $100. So this line right here, 3 cars and $100, twice gives me 6 cars and $200. That's a substitution problem. That's a fair trade. So now I have 2 houses turning into 6 cars and $200. So that's 6 cars plus $200 plus another car plus another $100 equals $2,400. Hopefully you understand how that fair trade just went. That 6 cars plus $200 came from those 2 houses. That's a fair trade. Now if I combine like terms here, I have 6 cars and another car. That's 7 cars. $200 and $100 is $300. And over here for the hotel, it's $2,400. So now if I just solve this equation and subtract 300, now I have 7 cars is worth $2,100. So how much is 1 car worth? If I divide by 7, I wind up with a car is worth $300. And there you go. So that was doing it with algebra. And like I said, you could do it with logic also, but on the video I'm trying to do this without having to sit here and explain the logic. I'm just explaining the algebra. So that's how you do that problem. And that is the lead-in to using substitution. We substituted by doing this fair trade right here. 3 cars is $100. I had 2 houses. 3 cars plus $100 is a house. I had 2 houses, so that turned into 6 cars and $200. Fair trade. Okay, that's what substitution is all about. We make fair trades. 4 quarters is $1. That's the same type of fair trade. If I have 4 quarters and you are looking for change, I give you for 4 quarters, you give me $1. That's a fair trade. That's what substitution is all about. So when we do these substitution problems, we're looking for fair trades. If I solve the equation for x, I can take what x is and plug it into the other equation. I made a fair trade. Okay, that's substitution. So that's as far as we're going to go on part 2. There's a part 3, and so it continues. It finishes.